Okay, so the second question, here we have it here. Okay, we are going to do the similar things that we are doing on question 1, but it's just what? A different question. Okay, so we expect different things. Okay, so let's start. Okay, so the first one here, they're saying, let star be defined as A star B is equals to 2A minus B. Okay, so this is the definition we'll be using in all our questions. Okay, so A star B is equals to 2A minus what? B. Okay, so the first question they are saying, is star a binary operation on the set of natural numbers? Okay, so you have to know the set you are working on. Okay, remember the first question, it was in a set of real numbers, but this one here is specifically on the set of what? Natural numbers. Okay, so we have to know what the natural numbers are. I said the natural numbers are just the counting numbers, 1, 2, 3, 4. Okay, no fractions in natural numbers. There are no fractions, there are no negative numbers. Okay, they start from 1 and then they continue to increase by 1, just like that. Okay, you can use them to count. You can't use 0.5 to count. Okay, all right, so that's the set of natural numbers, the counting numbers. So let's write them here. So natural numbers means you have 1, 2, 3, 4, 5, okay, until forever. So these numbers just be increasing by 1. So from 5 you go to 6, 7, just like that. Okay, so those are what we call as natural numbers. Okay, so now the binary operation that we've been given here, the definition is that A star B, okay, is equals to 2A and then minus B. Okay, so the question now is this guy here a binary operation on the set of these natural numbers here? Okay, all right, so we use the closure rule to test. Okay, so we get any two natural numbers and then test if after applying this binary operation here or this definition, our answer is also going to be a what? A natural number. Okay, if we can do that, then we'll conclude that it's a binary operation. If we can't, then we'll say RMI, it's not a binary what? Operation. Okay, so now from a set of real numbers, let's get any two numbers and then try to test them. Okay, so let's say, let's get A as 3, okay, and then we get B as 2. Okay, we get B as 2. So now let's apply this operation. So when we have 3 star 2, this is going to be equals to 2, okay, multiplied by 3, and then minus what? 2. So this here will be 6 minus 2, which is equals to what? 4. So you ask yourself, is this answer that I've gotten a part of the real numbers? Okay, the answer is yes there. Okay, 4 is a natural number, quite all right. Okay, so you just don't conclude after testing a set of one pair. No. Okay, no. So you try to test others. Okay, so now let's test this pair. Okay, so let's say I have 1 is equals to, okay, I have A is equals to 1, and then let me say B is 6. Okay, so let's test if these two are going to give us natural number. Okay, all right, so we are going to have A star 6 is equals to, so by definition, we're saying 2 multiplied by A and then minus what? B. Okay, so we see that here we are going to get 2 minus what? 6. So 2 minus 6 gives us what, guys? Okay, it gives us a minus 4. So you ask yourself, is this minus 4 here a natural number? Okay, is the minus 4 a natural number? Hello, guys.
No, it's not.
Okay, it's not.
It's not.
Okay, not a natural number. Okay, so it means our test there has failed. That operation there is not a binary operation. Okay, why? Because if I get two numbers from the set of natural numbers and then I apply that operation that I've been given, okay, it's giving me an answer which is outside the set. Okay, it is outside the set. So it can't be what? A binary operation. Okay, so it says since, okay, since -4 is not a member of the natural numbers, okay, then this star here is not a binary operation. Not a binary operation. Okay. All right, so someone might be asking, how do you know the numbers to test? Okay, so it's a skill that you gain over time. Okay? You can only gain it when you are practicing. Okay? If you don't practice, you won't gain the skill. So you have to be practicing. Then you always know the right numbers to pick. Okay. Right. So that's how we have disapproved that star there is not a binary operation because it's not obeying the closure rule. Okay. Yes, Rachel.
I have a question, sir.
Sir, is it always a sorry. Is it always a must that we should test using?
Hello, I didn't get the last
Hello?
part. Yes, you are saying?
Oh, I was saying that is it a must that when we are proving, we should always get the two numbers from the set that we've been given?
Yes. Okay, you
Do
always
not
try
test
to
it.
get two numbers from the set that you've been given. Don't get from the set that you have not been given.
All right.
Okay, the
Okay,
other
thank you.
one, who are the question? You can ask your question. There was someone else who was asking some question.
I've got a question.
Yes, please ask.
If you were to get other numbers, not the numbers that you got, can you also give us a number that is not a natural number?
Yes, guys. Okay, so the numbers that you use are not unique. Okay, they are different numbers. Okay, so there are a lot of numbers that you can get to disapprove this. Okay, it's not just 1 and 6. Okay, there are a lot of numbers. So a small hint is just for this specific question. Okay, since we had 2a minus b, right? Okay, a small hint on the number that you should get, make sure that this number here is just less than this number here. Then you get a negative number and that will disapprove your proof. Okay, so remember the natural numbers are positive and they are whole numbers. Okay, so if you want to disapprove that star there is not a binary operation, just make sure that the answer that you are going to get will be negative now. Then you would have proven. Okay, so you can get any set of numbers. It's not just 1 and 6. No, there are a lot of numbers that will work.
Sir, I got a question. So like when you are using the closure rule, are you
Yes.
always given the operation, like the formula that you're supposed to use, let's say 2a minus b? Like, are you always given the question?
Yes,
I mean the formula.
you are
So that
always given a formula to work with.
all right.
Yes. All right, so we have disapproved that star is not a binary operation. Let's go to the second one. Okay, the second one is saying what? Is star commutative? Okay, so let's try to prove if it's commutative. So we have A star B, which we want this to be equal to B star A. Okay, so remember from the definition, A star B was just simply what? Was just simply 2A minus B. So is this equal to, so if I have B star A, it means the positions are switched. Okay, where there was A, you now have B. Where there was B, you now have A. Okay, so it means this would be 2B and then minus A. Okay, so is 2A minus B the same as 2B minus A? Okay, so the answer there is no.
It's not.
Okay, just by looking there, you can tell that they are not the same. Okay, but if you are doubting yourself, you can always try to putting actual values there and then try to find the answer. Okay, you can always do that. So let's say, for example, which numbers will work here? Let's say A is 4 and then B is 3. Okay, so if I use this guy, I'm going to get 2 multiplied by 4 and then minus 3. So is this here equal to, if I'm using this, it's going to be 2 multiplied by 3 and then minus 4. So here you are going to get 8 minus 3. Then on the other side, you're going to get 6 minus 4. Okay, so we see that 5 is not equal to what? 2. So it means this here is not equal to each other, okay? So if you're doubting, you can pick any 2 numbers from the set that you've been given and then try to put them and see if they are equal, okay? Because there are some expressions that are not directly, okay? You cannot know just by looking at them that if they are equal or they are not, okay? So you need to test. So you can pick any 2 numbers from the set that you've been given and then you test like they were have done. So we see that 5 is not equal to 2. Okay, so we conclude that this guy here is not commutative. Okay, so when you're done asking your question, please be unmuting yourself. Okay, so if you have any questions, you can ask. Okay, Jack.
Sir,
yes.
This is commutative method, isn't it? So when you're using the method, both sides should be equal.
Come again?
I'm saying when using this method, both sides should be equal.
Yes.
Like the figures. So if you have 5, since here on the left hand we have 5, then on the right hand we have 2. So it's supposed to be 5, 5 or 2, 2.
Yes. So for this proof, to prove that it's a commutative, then you must have the same numbers on your left and your right.
Okay, thank you.
If they are different, then it means the proof is not true. Okay, so you disregard it, you say it's not commutative. Okay, so for any questions, you're free to ask. Otherwise, we'll go on and evaluate, test for associativity. Okay, so this one here. So is this star associative? Okay, remember we are testing this. So in the associative part, it becomes tricky. Yes?
Hello?
Yes, you can ask your question.
I want to ask, it's on the first solution.
I can get you.
Given it's the definition.
I can't get you. What are you saying?
So is the operation.
Guys, help me. Is anyone able to get to what she's saying? I can't get that. Anyone who can get to what she's saying? Okay, I can't get what you're saying. I can't get your question. Hello?
Hello?
Yes, what's your question?
No, that one was another one. Sir, I want to ask, like, on the first example, to be sure, can I use the closure law, like placing numbers?
To test for what? For commutativity.
Hello?
Yes, I can get you
To
now.
test,
I'm saying to test
yes.
what?
I'm saying, like, on the first example, can I use closure law?
To test for what?
To test for those for the question that you give us, like, what's the question? I didn't write the question. Like you were just yes.
This
Like
question here.
yes, the way it is here. Yes.
Yes, when
So
testing.
you were solving direct.
Okay, I get. Okay, so I was solving direct, and then can you use the numbers on the closure law? Okay.
Yes.
Like on the closure rule, we've been using numbers on the closure rule, right? And guys, we've been using numbers on the closure rule.
Yes.
And yes, on the commutative part, like this one here, we just concluded that this 2ab was equals to 2ba. Okay, so if you want, you can get two numbers from the real numbers here and then test them. You'll see that they're going to give you the same answer, so it will remain commutative.
Okay, sir.
All right, so
Okay,
here now
thank you.
we are on C here. We are testing what? Associativity. Okay, so on associativity, don't get confused, guys. Always refer to what? The definition that you've been given for your binary operation. Okay, so let's test and see if it is associative. So we have A star B and then star C. So B star C will be in the brackets, and then we are trying to prove that this is equals to A star B in the brackets and then star C. This is what we're trying to prove. Okay, remember the definition that we are using. Let me write it on top there so that we don't get lost. So we are using A star B is equals to, okay, we have 2A minus B. So this is the definition that we'll be using. Okay, so it's just the A's and the B's are just going to be changing, but it's the same. Okay, so here we start with what is in the bracket here, and then here we also start what is in the bracket. Okay, so this will be A star. Okay, what is B star C? Okay, we are using this definition here. So the two numbers now, or the two data that we are involved with now, okay, are B and C. Okay, so meaning where there's A here, we've put B, where there's B, we've put C. Okay, so if I do B star C, just like the first one, it will be what? According to the definition here, it will be 2, where there's A, I'm putting B now, and then where there's B, I'm putting C. Okay, so this here will be our what? B star C. Okay, so our B star C will just be 2B minus C. I hope no one is behind there. Okay, and then you're going to say this is equals to, what is A star B? A star B is just this here. Okay, so we are going to write 2A minus B in brackets like that, and then you're going to say star C. Okay, so now we have these two that are under the binary operation. We have A, and then we have this whole thing here is taking the place of what? B. Okay, so A star 2B minus C will be what? Remember, this A is the A, and then this whole thing is taking the place of what? B. So in this expression here, we're going to write 2. A is still A, so I'm going to write A. Okay, and then in brackets, I'm going to write the value of this B. So this B now is 2B minus C, so I'm going to write 2B minus C. Okay, and then this is equals to, and then here, okay, we have 2A minus B star C. So this 2A minus B is taking the place of what? A, from the original expression, this one here. And then this C here is taking the place of what? The B. So according to this definition here, if I have A star B is 2A minus B. So if I have 2A minus B star C, okay, this whole thing is the A. So I'm going to write from the definition, I can say a 2, and then where there's A, I'm going to put this thing that is representing A, which is 2A minus B, okay, and then multiplied by, minus, we have to subtract there, okay, minus B. In this case now, our B, this one here, is just what? This C here. So we're going to write minus C. Okay, the one who has a question, you can ask.
Okay, according to the you've put before the equal sign, you said 2A open brackets 2
Oh, yeah.
minus.
There should be a minus here, right?
Mhm.
Yeah, I missed it. Okay, so here there should be a minus. Okay, so it's A star 2B minus C, so meaning I have 2A and then minus the place of B, which is this. Okay, yeah. Thank you for that. Yeah, I didn't see it.
No.
All right, so this is what we have here. Someone has a question? Yes?
So I was kind of requesting you if you could like get back, rewind yourself a little bit concerning the third part.
The what?
Concerning the third part, I was like left behind, so I was kind of requesting you to
This part
get
here?
back just a little bit. No, the third part.
This one?
Yeah, this same one.
Okay, so here we are applying the binary operation. Okay, remember the definition is this one that we are using, right? Okay, so we're using this definition on A star 2B minus C. Okay, so the place of A is still A, but the place of this B here, we have 2A, 2B minus C. Okay, so according to this definition, we have a 2, this is the 2 that I've put here. A, this is the A, and then minus B. But this B now has been replaced by the 2B minus C. So this is the 2B minus C that you can see here, representing the B. Okay, and then on the other side, we do the same. Okay, so this 2A minus B is now representing the what? The A, and then this C is the B. Okay, so from the definition, I can see a 2. This is the 2 that I've written here. Then that 2 should be multiplied by A. So our A now is this 2A minus B. So this is what I've put here. And then minus our B, but our B now here is what? C. So I've put minus C. Okay. Have you seen where it has come from?
Yeah, thank you.
All right, so this is what we have on the left, and that's what we have on the right. So we can try to expand. So we are going to have 2A minus 2B plus C is equals to, okay, this will be 2 multiplied by 2A to be 4A minus 2B and then minus C, okay? And then you ask yourself, is this left-hand side, okay, equal to the right-hand side? Okay, so clearly, without even testing with any numbers here, you can see that the left and the right, they are not equal. Okay, if you want, you can plug in numbers there. It will still show you that they are not equal. Okay, so the left-hand side and the right-hand side, they are not equal. Okay, so meaning that this operation here is not associative. Okay, it's not associative. Okay, so any questions there?
I have a question.
Yes, please ask.
2A minus 2B minus C, like 2B minus C is in the brackets, right? So take for instance, you forget to put the brackets, but then you do the process to the next one, and then you see that the numbers are different, and you write it's not associative. Are they going to mark your process wrong or your answer wrong because you made a mistake or something?
Okay, so at university level, the marks are given at each stage, okay, or at each step that you are showing in your solution. Okay, so they don't only mark the final answer; they mark even the steps. No wonder they are on the exam paper. They will always say, "Show your working." Okay, so if you are coming correctly like that, and then you make a mistake somewhere, they will give you marks on those correct steps that you had. Okay, and then on that step where you made a mistake, they won't give you a mark. Okay, so if the question maybe it's out of 4 marks, you get 2. Okay, you get 2 or you get 3, depending on who's marking. Okay, so if you have 2 expressions that are either being added or being subtracted, always put them in brackets like I was doing here. Okay, don't forget the brackets. All right, so that was the question on associativity, and then let us look at the other question. Okay, someone has a question? You're free to ask.
Yeah, I'm still confused on that part. That's A.
Which A?
this part where you wrote 2a minus, where is the minus coming from? Because if we see on the equation there, I can't see the minus on the first one where there is a star b.
Where there's a what? Mention what you can see here.
No, on
Here.
top there, on the equation that
Here.
were given. Yes,
There's a
there is
minus
a star
here. So there's 2a minus b. Are you able to see the minus there?
Yeah, so we have to apply it even on this one, on the first part when writing.
Yes, that's what I said. Okay. So whatever we'll be doing, always apply your definition there. Don't forget your definition. Immediately you forget your definition, you won't find the correct answer. Okay. So we are applying that definition to prove that it's associative. So at each point, as long as you are associating two items or two expressions, you're going to use that same definition there.
Right. Thank you.
Right, you're welcome. Okay, let us look at the last question there, which is evaluate. Okay, this guy here, evaluate 2 star, and then I have in the brackets 3 star 1. Okay, so let's do that. Okay, so remember that our binary operation was defined as a star b is equals to 2a minus what? B. And then we've been given to evaluate 2 star. Then in the brackets, we have 3 star and then 1. Okay, so we always start with what is in the brackets there. So let's apply this binary operation on 3 and 1. Okay, so if I apply the operation here to be these 2 that is outside, then star, then let us apply on what we have here. Okay, so you put them in the brackets. So it will be 3 star 1. So wherever there's A, I'm putting 3. Wherever there's B, I'm putting 1. Okay, so it will be 2 multiplied by 1. I mean 2 multiplied by 3, then minus what? 1. So this would be equals to 2 star. Then in the brackets, we're going to have 6 minus 1. Okay, so it means we have what there? 2 star 5. So this is what we have here. And then you apply this same definition here on these 2 and the 5. Okay, yes, someone else has raised their hand. You're free to ask.
I was asking if you can kindly question how we have constructed the left side, the right hand side.
How of what? No, can you repeat your question? I didn't get it. What? How of what?
How you have replaced the numbers on the right hand side.
Oh, okay. So I'm just following what I have here. Okay, so here we have been asked to evaluate this guy here. Okay, so I have 2 star, and then in the brackets I have 3 star 1. So you always start with what is in the brackets. Okay, so you write 2 star. This is the 2 star here, and then evaluate what is in the brackets using this definition here. Okay, so if you are given 2 numbers, then they should be equal to 2a minus b. Okay, so this 3 is acting as our a, this 1 is acting as our b. So I'm going to write 2 multiplied by a, which is 3 now, and then minus b, which is what? 1 now. So that's how I got the 2 multiplied by 3, and then minus 1. So 2 multiplied by 3 is 6, and then minus 1 is going to give you 5. Okay, so that's how I ended up here. And then when you reach here, you still use the same definition here. Okay, so now it's 2 star 5, meaning that our a is what? 2. And then our b is what? 5. So we use this definition here to be 2 multiplied by a, which is 2 now, and then minus b, which is 5 now. Okay, so we are going to have what? 4 minus 5. So this is going to give me a minus 1. Okay, so that's how you evaluate there. So you just follow whatever you've been given there. Okay, so any questions there, guys? Yes, Rachel.
So my question is, I usually problems when you reach on 2 star 5.
Mm-hmm.
Yes.
Then what's
I
the problem there?
only 2 star 5.
What's the problem?
Hello? Say if you can kindly repeat
Okay,
the
so 2 star
explanation.
5 there. The 2 star 5 there, we are using this same definition on top here. Okay, so 2 star 5, it means this 2 is now our A, then this 5 is now our B. So it's like A star B. What is A star B? A star B is just 2A minus 5 minus B, right? Okay, so in place of this A now, we are putting 2. Then in place of that 5, in place of this B, we are putting 5. So this is what I've done. So here, that's where your A should be, and then there, that's where your 5 should be. I mean, that's where your B should be. Why am I saying 5? So we are just replacing there. So you put your 2 there, you're going to have 4, then minus 5. So 4 minus 5, that's how we are ending up with the -1 that you can see there.
Okay, sir. Thank you.
Right, you're welcome. Okay, so that was our last question. Yes, you have a question?
Yes, like I wanted to ask, at first, like when dealing with them, when you're dealing with 3 numbers, where there was 2 star, why you are replacing making the A to be 3 and the B to be 1.
Here.
Yes.
Okay.
So now I'm asking, like at first you brought in that the formula, the 2A minus B, whereby you made A to be 3 and the B to be 1. And at some point when you are done with those 2 numbers, now you reached at the stage where you had 2 star 5.
Yes.
Bring again the same formula that you are dealing with at first.
Yes, you bring the same formula that you are dealing at first.
It's like in short, what the sir was trying to say was, first of all, you have to deal with the blankets first. The blankets, you deal with them. That's the first thing you have to do. So you have to use the same formula which you've been given there. You just substitute like what he did here at first, where there is a, which at first our A was 3 and our B was 1. So after doing that, after finding 2 star 5, then after that you use the same figures you are from finding, and then you put them again in the equation that we've been given, the operation. So that's how the
meaning the first step was to get rid of the brackets.
Yeah, you first have to deal with the brackets first. That's the first thing. Then from there you substitute. When you find the answers, like 2 star 5, and then you use the same ones to find the final answer now, but using the same operation, the equation there on top. You just need to substitute.
Okay,
all right, thank you.
So that's the expression, guys, okay? So when you're dealing with binary operations, okay, always remember to use the formula that you've been given, okay? Always. If you won't use the formula, then whatever you'll be doing will just be wrong, okay? Just be wrong. So always use the formula. So it's the same. If maybe the binary operation was a plus, right? And then I say 2, okay, plus, and then I say 5 plus 7. So what do you do in this case? You just say 2 plus, and then you work on what is in the brackets, right? So 5 plus 7, you get 12. And then you say 2 plus 12 is what? 14. It's the same thing that we are doing. It's just that now the operation that you are using is a special operation that is defined in a certain way, okay, given in the question. All right, so that's all about binary operation. Those are the questions that they will ask you. Okay, is it a binary operation? Is it commutative? Is it associative? And then evaluate. That's all. Okay, so make sure you master them. There are very good notes on the drive. Okay, you have those that are typed. Okay, you can pass through those, or you can pass through the handwritten notes. Okay, so the handwritten notes have a password. The password is PB in capital letters. Okay, and then 4511. So if they ask you for a password, just put this as your password. Okay, so you can pass through, just practice questions, and then you see that you know how to do it. Okay, so I'm going to give you an assignment. Okay, so you submit it. Okay, so the assignment is, okay, if the binary operation is defined by A star B, like this one, A is equals to, and then I have minus 2 to the power A multiplied by B. Okay, so the question now is this star a binary operation? Okay, so this is the simple question. So this is your task, so you can screenshot. Okay, you can screenshot and then you send in the group. So this is the task. Okay, so prove here, is this type binary operation on that? Okay, I've forgotten to give the set here. So the set should be real numbers. Okay, so you always be given a set. It's a binary operation on real numbers. Yeah, so this is your task for today, guys. So practice it, and then I'll send more practice questions later. You can try them at your own. Okay, I'll even send the solution. So you just have to strive until you find the same solution that I did. Okay. All right. So any other question, guys, before we close the class?
Password. If you can repeat the password.
The password is PB4511, capital letters, PB4511. That's the password. All right, guys, have a blessed night. Okay, continue studying.
Oh, I've got a question.
Yes.